I just woke up, got my first cup of coffee. I'm ready to write some Rust. How are
Nice.
you doing?
I'm good. I'm ready to learn.
Hell yeah. Let's see. Sharing screen. Cool. So let's just check out where we were last time. This is our code and chill repo. I'm going to share it again in the chat because it's really great for people to follow along. Maybe try some coding themselves. At the moment, we only have one contract, which is this CW721 piggy bank. And if you want to play along and don't want to worry about like setting up your developer environment or whatever, you can do this cool open in Gitpod thing. You like sign in with your GitHub, and then you can basically just start a workspace with everything you need to get up and running. No needing to install Rust or figure out weird things about Windows. So definitely recommend giving that a try for lots of people. So yeah, Gitpod is pretty awesome, but I'm not going to be using Gitpod. I'm going to be using like normal VS Code today. Is there anything, while we're just starting, is there anything in particular that people would really like me to cover today? Like maybe some aspect of, maybe you want me to explain something, or I'm taking requests. Does anyone have, and you could, if you're not the kind that likes to talk, you can feel free to put it in the chat. If you have some questions that you would like me to answer today, just put them in. That's what these spaces are for.
I just wanted to see what this was all about. Get to meet some of you guys.
Cool. What kinds of things are you working on?
We're trying to build a role-playing platform, but it's not going to involve a lot of coding. It's more Discord, and we might have to program some smart contracts for NFTs and stuff, but
You came to the right place. We're programming some smart contracts for NFTs. Awesome.
Nice.
Do you want to talk a little bit more about the game, or would you rather not? What sort of is like the high level thing? Maybe we can talk about some relevant stuff that might be useful for you when you're working on the smart contracts for it.
We're still ironing out a lot of the details, but basically we play sometimes online on Discord, Dungeons & Dragons. But what I wanted to try to do was integrate some of the NFTs from, if we have an auction house where we have items that could be considered powerful or players would want to keep and trade, we want to integrate them with the game so that they would have to be probably authenticated by Discord, at least.
Yes.
It would detect that you have them, and then you wouldn't even be able to play if you didn't have a membership in our DAO, whether from NFT or from staking or something.
Cool. So there's actually a couple examples of this. So this one's called Starrybot. This was a project that launched with like during Hack Juno, and it's all open source, which is another great thing. So if you want to take this code and modify it to your own needs, that's possible. And it already supports token gated roles with the CW721, or basically NFT contracts, which might be useful to you.
Yeah, I saw that in someone else's Discord that I was joining, and a similar NFT project I'm supporting. It's pretty cool.
Yeah, so it might be a good thing to look at. Again, it's open source, so if it doesn't do exactly what you want it to do, you could probably modify it. I think there's some other ones as well, but I'm not sure if those ones are open source, so that's why. Yeah. But as you can see, a lot of people really just use it mostly with NFTs. Cool. I'll make sure to cover some stuff that can be useful to you.
Because I know Stargaze pretty well. There's so many NFTs.
Yeah. You were saying?
Oh, yeah. There's a lot of potential places to launch on Juno. I wonder if it matters because that Starry thing uses the Stargaze platform, doesn't it?
Oh, it's generic. You can use it wherever. And the contracts we're making today can also work on Stargaze as well.
I'm not actually a computer programmer, so I'm really basic here. But the guy that works with me, he's a software engineer, but he's not here today. So yeah, I just wanted to check this out.
Cool, sweet. Welcome. Let me know if you have any questions. Same thing for everybody else. But yeah, I think so. Let's check out where we were last time. This is the wrong project. Oh wait, I'm still learning how to use VS Code because I use Emacs, and it's still a little confusing to me, but I will figure it out. If I'm doing something stupid, just let me know. I appreciate the help. All right, that's not what I wanted to do, but whatever. I also normally don't use Mac, so I'm extra confused today. But this is where we were at last time. We've been building a custom NFT contract, which is a piggy bank. And when you deposit funds in the piggy bank, they stay there. They stay with that particular NFT until you burn it, at which point the funds are released. Last week, we also implemented making the NFT a little bit dynamic so that as you add more funds, it can change the appearance of that NFT. And I think today it might be good we have one little file in here, and let me just try to make this a little bit bigger. Is this font big enough for people, or should I do one more?
It's good for me. I was just about to ask about zooming in.
Okay, cool. So right now we got this one big file. And since we've got some new people here, I think it'd be good to go over some of this stuff, but this file is starting to get really big. So I think what we're going to do is we're going to break it up into a more typical file format for CosmWasm contracts. So if we look at like a particular contract, like I like the DAO contracts as an example. Oftentimes the contracts are very much split up into like this kind of format where you have a contract file, which is like your main logic. You have your error file, which contains all the errors. You've got your lib file, which basically has the various different modules which are exported. You've got your message file, which is like the API, if you will, of your smart contract. These are all the messages that it supports. And then we have sometimes you have a query file if it's like a really large contract, but sometimes not. Then you have a state file, which has all the different state your contract contains. And then finally, a lot of times there's a test file, even though oftentimes tests are written in the same file of the thing that they're testing. So maybe it's a good idea today, we can go through and start breaking this up into the different files, and at the same time, we'll revisit some things, if that sounds good to people. It'll be maybe like a quicker session today, but I think it'll be a good review and we'll learn some extra stuff. We got pretty far last time in terms of implementing dynamic NFTs. I'm curious if anyone got a chance to like play around with them afterwards or give it a try. All right, I'm gonna take that as a no. Cool. All right, let's get started. So we got this very big file here, and there's a lot in here. I'm going to start by just making the files that we're going to use. So we're going to have one called contract. We're going to have one called message.rs. Again, that's going to contain basically like the API of the contract, if you will. We are going to have one called state.rs. And we're going to have one called error.rs. Yep. And we're going to have one called test. Cool. So let's start with the contract ones. I'm just going to grab all this stuff. And we're going to just flop it over here. Boom. And then I'm just gonna start deleting stuff. All right, I can already see some dependencies are not going to be relevant for the contract stuff. Like this error, we're going to move that to the error file. Great. This is also going to go to the error file. So it's a payment error. Maybe someday AI will be able to just do this for us, but I'm just going to delete stuff as we go. Awesome. All right. Ooh, this is crazy. So this is like more of our messages, this struct metadata extension or execute extension. So we're going to put all these things, especially this guy here, and we're going to put all these guys in the message folder. I'm really bad with VS Code, sorry. Great, now we moved all those. This has our different messages, great. Oh, this is an error, so we're gonna put this in the error folder, or file. I said folder, I meant file. All right, so these are pieces of state, balances, and denom, so we're gonna move those to the state folder. And here's our contract, which is actually defined as a module. We're actually going to change that, but for now we're just gonna plop it. We're gonna plop it in. Oh my gosh. I do not know all the keyboard shortcuts for VS Code, and so I get really confused. Cool. That's that. And then finally we got like our little test here. There's already a module called tests. So we're actually gonna this will start to make sense when we do the thing. Or when we wire it all up. Sometimes stuff like this takes a little bit of work, but it's going to save time later and it will help us maintain our sanity rather than having everything in one absolutely huge file. All right, so we're going to start having to fix some bugs here. We've mostly put things in the right spot. So let's look at an existing, so this is from DAO. This is a normal lib.rs file, which kind of just defines the package. So we can see that there's like a lot of modules are like exported here. In fact, we can mostly probably just copy this, and let me just explain what's going on here. Obviously, we don't have a migrate module, and by module, it's looking at these like file names here. So it's complaining that a query module doesn't exist because we don't have a query.rs file or anything associated with it. So we'll remove that. Cool. Now we've got, this is our lib. So think of it like when when this library is like loaded, or when the compiler is looking for something to compile, it's by default, it's going to look for this like lib.rs file or a main.rs file. And these are the various modules that are included inside of it. This is like a little helper that means when we generate the documentation for this contract and we put it like on crates.io or whatever, it will include this README in the documentation that is auto-generated. Maybe we'll get to like auto-generating documentation today. Or I can't remember, did I cover that last time? I might have covered auto-generated documentation last time, but I know I've definitely talked about docs.rs. And like, this is one of the best features of Rust, is that you can actually just automatically generate all your documentation. So this is all just auto-generated. They didn't have to like make this website or anything. Every like response, if you have like code comments on it and stuff, like it's all auto-generated. It's really awesome. So we can make that same thing for our contract. Now we've probably got like a bunch of errors. I see here's an error. I've never done this here before, but sweet. So as you can see, like your editor, like VS Code, has some helpful suggestions. If you like look at a squiggly line, it'll tell you what's wrong. So here it's complaining about an unused import. So we're going to move this to the file that actually needs it. So for example, here we're using the CW CERD. We'll make sure that is included. I'm really not used to the setup, but I'm making do. As you can see, it doesn't have this custom message. So again, if I click on this light bulb, I can add import custom message, and then that error is going to be gone. Here's another error. It's complaining about cannot find empty in this scope. Again, all we got to do is just import empty. There's a couple options. We're going to use the CosmWasm one. So that just added it up here. And then it seems like that's all that we need for this file. So this file doesn't have any more squiggly lines or red errors in it. Okay, great. So here we need to import the map from CW Storage Plus. And we need to import item. And we need to import U128 from CosmWasm standard. So now our state library is looking great. Awesome. As for tests, I guess use super does work here. Using super means it's like importing like basically all the dependencies that are exposed here. So if a dependency was defined in like another module higher up, like it's importing that. It's complaining that we don't have the entry crate. We're gonna fix this in a bit. Cool. So let's look at these complaints and try to get these fixed. This is just an unused import. This is also an unused import. Eventually you'll get really good at solving some of these like Rust like errors basically. And you basically just go through one by one like this and then just solve the squiggly lines. You can also run it in the terminal. So if we try to cargo build, it's going to tell us everything that's wrong with our package, including just warnings. So here's a bunch of warnings. This is an error. So basically, whenever you're refactoring, usually just can go through and just look for the squiggly lines This is an unused import, so we just get rid of that. Get rid of that. Get rid of that. Those are all unused. These are unused. Cool. All right, so this is an error. Again, the Rust error tells you exactly what's happening here. So it says cannot find type instantiate message in this scope. So inside of the scope of this package, there's no instantiate message that it can look at. To solve this, we are going to, if we click here and click on this little light bulb, it says import crate message instantiate message. And this is what we want. So what's happening here is we've got our message crate where we define instantiate message. We define it right here. And so we're importing from this crate into the contract. And I'm actually going to fix this up a little bit because see how we've got actually another module here, this entry module. So this is an artifact from when we had everything in one file. Now that we have everything in multiple files, we've got a contract module. And then now inside of the contract module is another module. This is not what we want. So effectively this would be like, and maybe we could still do something like this where it's like contract entry. This is messy. So we're actually going to get rid of this entry module. I'll show you how. So first thing is we are going to actually remove this module keyword. I'm going to scroll back down and remove the matching parenthesis. In Emacs, I would not have to scroll down to do it, but whatever. And then we're going to reorganize our dependencies a little bit. And we're going to get rid of this build flag. We're going to reorganize our dependencies a little bit. Some of them can just go this. And then let's look at another. So one of the things I always do is I always consult like other contracts to see how they structure stuff. See how like in this contract, like instantiate is a public function and it's got this flag on top of it. And here we've got a public function as well, but notice that this just says entry point. I want to talk about this a little bit because it's important and something you're going to come across. This flag is basically saying, so we're actually going to replace this. So what this flag is saying and is basically just it's configuring an attribute, which is this entry point attribute. The entry point says the WASM compiler that this is a callable function on that WASM binary, and it's a standardized thing for CosmWasm. The entry points instantiate, execute, query are how you interact with the contracts, and you have to like basically say that those are entry points. Now you don't all like. Unfortunately, it's not unfortunately. The way it is like you cannot have two there can only be one execute entry point for each contract, and there can only be one instantiate entry point for each contract. And sometimes, like if we look at this cargo.tomo file, like we're using a CW721 base file, and that has entry points as well. If we get rid of this features library here, and we tried to compile this into WebAssembly, we would get an error that would say duplicate entry points. And so we had the library features flag, which is basically this line of code right here. And if the library feature flag is enabled, then these entry points will be removed. And then you can just use the library as a library rather than as another contract. I hope that makes sense. So yes. All right, let's just go replace the query one. And we're almost done here. We've got a few more bugs to fix. Oh my gosh. It doesn't auto format it in VS Code. Does anyone know how to get that working? Because I don't want to have to go through and... wait, I have another trick that we can use for that, but I'm surprised auto formatting is not working in VS Code. Oh well. All right, so we have a couple more squiggly lines to fix up. So if we do cargo build again, we've got a lot more basically just seeing missing values. Use of undeclared type, not found in scope.
Oh, just regarding the formatting, you may have to set the default formatter. So if you do Control-Shift-P, it brings up the command palette, and then you could type formatter. And then there might be something like set default formatter. Format document, maybe.
Oh, Sick. All right. Thanks for the tips. So I guess maybe then for Rust, there's like a default formatter. Let's see.
If we went back to the same command, it had a gear on it, so it might bring you to that setting right away.
Oh, okay.
It's
all
the
right,
first
cool.
option on what you were just searching.
Perhaps not. VS Code's kind of weird just because it's so like extendable.
I know. I get, but this
Yeah,
is
right
why
there.
these. Oh wait, default. Oh wait, I think what we want is format unsafe. Format a file unsafe. Formatter must be available. Yeah, I think this is what we want. Format unsafe. Great, we're all learning VS Code together. Let's just try it out. So I'm gonna do that. Perfect. Awesome.
And
Cool.
I just to clarify on the config attribute above, so when the feature set to library is set, then it won't use these entry points? Or
Yeah, there's a not here.
okay. So you're overriding those entry points?
Yes, basically.
Okay.
If the library feature flag is set, so like basically there's a not here, which makes this like a little bit more confusing.
Right.
But
Like an exclamation point.
but so basically if this is true, include this entry point.
Okay.
If you set library, it's gonna be false. So include wait, let me just find the docs on it.
I
So
think
yeah,
I understand.
it's just conditional compilation basically. So yeah.
Okay, thanks.
So basically, if you include it like here with this features equals library, then it will not compile this instantiate message. But you would still get access to these kind of functions that are also in the library, or maybe like some of the messages that you might use. So for example, let's say you were writing another like a game contract that was like basically using a lot of the messages in this contract. For example, you might want the execute extension from this contract because you want to be able to call deposit or update token URI from another contract. You would need to import it with the feature flags. Otherwise, it would not compile to WebAssembly correctly because it would say, hey, I'm trying to compile this contract. I can only have one instantiate message endpoint and there's two. Which one do you want me to use? So cool. Let's fix up some of these other ones. These are all basically just missing dependencies. Oftentimes, I guess if you have multiple, there might be multiple things called execute message in your dependencies. Then you have to choose which one you want. And notice here in our quick fix, we have two options. We can import create state denom, or we can qualify as create state denom. That's basically the difference between clicking this will add an import statement up at the top. So you can see that we've imported denom from the state module, but we can also qualify, which is basically it just adds it right here. Both are valid. I kind of like the just import it up at the top because it just a little nicer. But both are valid. Let's see. Query message here. And query extension. As you can see, having an editor to like really help you like solve these bugs will just save you like a ton of time. And then let's see how we're doing. Oh, we got awesome. So we actually got our contract to compile. So we know that that everything's working pretty well. We've got a little warning here. So this is basically it's complaining that this is an unused variable. So if we put a little underscore in front of it, the warning goes away. And so we cargo build. Great. Now we've got everything's great. So let's fix up our tests a little bit because they're still broken. So we got rid of the entry module. We don't really need that anymore. This is just, we need to import the instantiate message. We can probably get rid of this use super here, but it's going to throw a bunch more errors. So we're going to import this instantiate message from the contract crate. We're going to import contract name also from the contract crate. Oh wait, did we export it? All right, we need to make these public so that we can read them. Now, if we go back here and we try this, yes, now we can import it from the package. Here, we also just get rid of this entry thing. More entries. It's actually going to be really nice when AI can just do all this. So basically, yeah, I'm going through here and let's just try search and replace. Oh, no. I don't know what the keyboard shortcut is in VS Code for search and replace, but see how we've got like a lot of these entries here? We could just actually just get rid of those with search and replace. It's your friend. So we've got all these different things, and if we replace them with nothing, now that just saved us a bunch of time. Great. Always try to be as lazy as possible when programming. It's all right. Now we just did our test. So if we cargo test here. Ooh, okay. All right. So we did cargo test, and notice this file here. It's coming from our examples file, and it's coming from schema.rs. That's our little schema file here. And because we moved things around, well, execute message, instantiate message, and query message, they're all in this message.rs file, or this message.rs module. So we can fix this really easy. We just add message here, and the squiggly lines go away. Yeah, I love it when they go away. All right, we had a failure here. And again, let's look at our little test. This is probably just another renaming thing. On line 107, which is this assertion statement, we're checking the error, and we're expecting the error is equal to this message. But as you can see, we're missing that message again because we've moved stuff around. Moving stuff around is a pain in basically every programming language because things like this happen. So now we've got another error. It's the same thing on 148. So it's this assertion statement. And again, we can fix that by just adding message there. And now our test should pass. Oh, what do we do? Oh, these are doc tests. Okay, great. This is a good thing to talk about. So did you know that Rust can actually run tests that are in your documentation and can run code in your documentation to make sure the code in your documentation is always up to date? It can, and that's what's another one of the really awesome features about Rust. So it's actually complaining about this code here, which isn't even really Rust code. But so we actually have to and the reason it's complaining about it, which is it's this line right here. So this line is including the README file in the generated documentation. So one thing we could do is we could just get rid of this line here and then cargo test, and now everything's okay. So because the README file is now being included in the generated documentation, it's basically running through and making sure that all the code examples in here work. So let's try to solve this. And Google is definitely your friend, or ChatGPT is also your friend when you're trying to solve these things. So a lot of times it's just framing your question, Rust doc test, ignore, and apparently there's now a no run attribute. So maybe we can still include this in the generated documentation. All right, well, that didn't work. Stack Overflow's lies. Oh, that's no run will compile your code but not run it. So we actually just want ignore. That's why it always helps to read things. So now we got, boom. All right, sick. Let's just check our Git. All right, we made a lot of changes. We could use Git here, but I'm just going to show you guys the command line stuff because, yeah. So you can add files to Git with git add. You could add them individually, or this dot means like basically just add everything in the current directory. Git status will show you the status of your branch. So these are the changes that we're going to commit right now. And then we can commit them with git commit. You can do -m for message, which is really great if you just want like a one-line message and just be like reorganize code structure. Cool. And then last, we can just push it. If you type in git remote -- verbose, you can see these are the different Git servers or that I'm connected to. So the main one is origin, which is Cosmos contracts, code, and chill. So then I'm going to do git push origin, and then the name of the branch, which is just main. I would encourage you, if you're going to do work on this contract and maybe want to do a PR, you can check out a new branch, which is git checkout -b, which is branch, and then branch name. So now I'm on this new branch, which is fun. Cool. How are we doing on time? All right, so we've been going for almost an hour. Is there any questions at this point, or something that people really want me to cover before we get on to like next stuff? Let's see, is there anything in the chat? Not really. Cool. So I'm trying to think of what else might be good to do today. Let's like go through and cover a bunch of the stuff we looked at last time. So now that we've got things a little bit more organized, we've got our error files. Great. This is our custom contract errors. We've got the lib file, which is basically linking all our different modules together. You can think of this is all the stuff that we're exporting as well. We got our message file, which is where we've got all the messages of this contract, and that's great. We've got our state file, which has our state, and we have our all important tests, which mean that we can help trust this code. One of the things we worked on last time is we worked on 2 ways of creating dynamic NFTs. So the first one is like a manual one. So we've got this update token URI method. And this basically checks whether or not the person sending this is the minter or the admin. And if they are not, it returns unauthorized. And then basically it just manually updates the token URI. So this is a pretty helpful pattern, and you could use it in combination with other contracts or you could also use it with like bots or whatever to achieve the kind of results. The other thing we did was in this execute deposit method, we check the balance and then we return a different token URI like as a result. So basically this one works so that like when you deposit more funds, the token URI is just like automatically updated. There's no manual intervention. And then I think last time I also talked about some of the other options for making like dynamic NFTs. I think I think that we're almost ready to turn this project into a game. I see a question. Oh, that's a good question. What version of CW721 am I using? We can check in the cargo.toml file, which lists out our dependencies. And as you can see, I'm using version 0.17, which is, I believe, the latest version of CW721. And I recommend that version as well, because if we go to GitHub, CosmWasm, CW NFTs is the name of the library, put it in there. And yeah, it is the latest release. We should actually tag this release. I'm going to make a new release now. I should have done this a while ago, but whatever. There's lots of really good stuff in this release. So I recommend using version 17 if you're working on custom NFT projects. Just some of the APIs have been really cleaned up a little bit. There's updated dependencies. One of the things that's really cool is that you can update the owner or the mint in the NFT contract. So previously it was not updatable at all. And that, yeah, there's just some nice small improvements in 0.17. So definitely check that one out and use that one. Let's see. Yeah, any other questions? This is a great time to ask them. Otherwise, I'm just going to keep rambling. And also just talk about what's next. I think that we're to the point where we have a solid base contract that we can modify this contract for a bunch of different potential use cases. And I think it would be really fun to turn this into a game. Of course, the first step is not to just write a bunch of code, right? We also have to like design our game. We should be designing it to think about, it should be simple or relatively simple. It should also be like ideally like fun. So that's something that we can work on over the next week. And if you're hanging out in the chat over the next week, like I'm going to be trying to post some various different ideas for where we can take this code next and where we can take this game next. So that'll be really fun. And then we'll get to work on it, and it should be fun. The other thing I wanted to cover is, so that's the next steps with this contract is we've got a really basic dynamic NFT contract. And so now we just have to design a good use for it. Now, when I presented this last time, I talked about an NFT trees example where you have like basically different stages of tree growth. And then the more you deposit into the NFT contract, the tree kind of grows. Now we could fully make that, but I think we might be able to come up with something like a little bit more exciting where with like monsters where they like eat each other and stuff like that. But the key thing is to design it before we like actually try to implement it. This is, I think, a good enough start, and then we can just modify it however we need. For example, this metadata extension, we can add like as many different attributes as we want. Here we could have, let's say if we're going to make a fighting game, we could add like things like a weight, we could add like height, you could add like strength, figure out different like character attributes or whatever. Before we get into that, it's good to have just like a solid idea. But we're going to be able to create all the on-chain metadata we need to like enforce the rules of our game. And then I think similarly like to what we did last time. So here we've got this, Wraith has a comment about add dynamism in the form of code execution. And we already have that here. So this execute deposit method will update the token URI differently based on like how much money has been deposited in the contract. And we could, once we design our game, we can use this simple strategy here to maybe we have like a function that's like execute cannibalize, or yeah, I don't think I spelled that right. And so that would eat like another like player or whatever, and you might get the money that's in their like NFTs or whatnot. And then maybe that would change like their picture to like dead or whatever. So yeah, so we're gonna be building that out like next time, but we really need to this week like just come together and like kind of design our game a little bit more. And I'm open to ideas. I'll be posting some more like later this week. And yeah, I think that's pretty much it. Another thing that we could potentially cover today, if people are feeling up for it, is actually like uploading the NFT metadata. We talked a little bit about this last time, and I mentioned tools such as NFT storage. This is a great website if you're working with NFTs, and it's really easy to use. So definitely check that out. I'm curious if anyone actually tried to upload the contract and get it working with the NFT storage. But there is one important part that we're missing, which is the metadata. So let's actually add that now. So we're going to actually add a metadata folder called metadata. And then we already have our structure here. We have a like folder 1, folder 2, and then they have the different states inside of them. So we're going to do 1, and then 2. And then inside each folder, we're going to need all these different files. Again, these are referenced in our contract, like right here. So let's do file full grown. Now there's actually some metadata standards for NFTs. So those are published by OpenSea. A lot of these are probably really familiar to you, like description, image, and name. So there's also attributes. Attributes are like, I think if you're familiar with NFTs, you might have an attribute like personality or sunglasses or like big eyes or things like that. These are how the attributes are formatted. Again, this is all just like JSON. I will post this here because I think it might be helpful to others who are looking to develop NFTs on wherever. But I think for our purposes, we're just going to use like name, image, and description. We're going to call this one the first tree. And if you're working on an NFT collection and you don't want to make a ton of JSON files, you can train like ChatGPT or whatever to make a bunch of JSON files for you. But we're just going to do it like a little bit manually for now to show you the idea. And then image, we're actually going to leave this blank now because we have to upload the image. This needs to be a URL, ideally an IPFS URL. Now one of the questions we could add is, again, we have our different states. So this is the seedling state. Ideally the image change each time, but we could also make the description change. So we could make it, then we go over here to sapling and we can, oh my gosh. So I just modified the description a little bit there. And then the next stage is tree. And then we have full grown. So now we've got our like different metadata files that represent the different states in our contract. So again, if we look, when you deposit like one Juno, it turns into a sapling. If you deposit 10 Juno, it turns into a tree. And if you deposit 100 Juno, it's like fully grown. It's a huge, ginormous tree. Now we'd have to like make some images for that. We might have another folder in here that's like the images. Again, for each folder, they have the same structure. This one stands for the token ID, and we'd have a 1, 2, 3, etc. Same thing for images. Is this making sense for people how we're like laying out the metadata folders? This is also something that you can script as well. If you're going to do this for 10,000 NFTs, don't fucking do it manually. That's the perfect kind of thing that you should totally like script. And there's, I think, some decent like tools and examples or tools out there for this kind of stuff. So then we would need to create like our metadata or like our images. I'm actually going to delete the other folders, but I am going to try to upload just one of the, let's just try Dali 2. Oh my gosh. Now we're going to generate some AI art. Perfect. This is the one. This is really like the best time ever to launch like NFT collections. It's just, it's so easy to like generate basically all the things that you need. I don't really like any of these, but let's try it again. All right, whatever. This is the one.
Close.
Now it's got more. Again, you can see where if you had to do this for thousands of NFTs, you're really going to have to like script things in order to get by. Now we're just going to do tree. This is a really good guide too. This NFT up guide. I would recommend that for people. And see how it's like organizing the assets. You got your assets folder, your images, then you just got your metadata. Yeah, so maybe give this a try. Good enough. And then finally we need like huge tree. All right, so we just made one NFT. That was like the process. We got the full grown, we got the images here and we got our metadata. But we still have to set this like image URL here, right? So again, this is something that's like better done with scripting, and tools like this NFT up can be very useful. Maybe we'll explore that some next time. But I'm going to actually do it manually just so you can understand what's happening a little bit better. You can upload like individual files with NFT storage. So we're actually going to do that. But you can also, I think, upload just like a folder. Oh, right now. So we're going to upload this full grown. And we've already got basically like our link. So we're going to copy this link. If we look at it, it's going to be, there we go. So that's our full grown tree on IPFS, which is cool. So we find our full grown JSON and we take this URL and this is the image right here. Cool. So we would do the same thing with the seedling. As you can see, don't do this manually unless you've got like a really small NFT collection. We're going to explore tools for automating in the next section or next session, because automation is super important if you're going to actually survive here. So we got like our little seedling file. We're going to replace the image there. Now, the fun thing is we're actually going to upload all these JSON files. Basically, we're going to upload all these JSON files, and they themselves will have an IPFS address. So it's IPFS inside of IPFS. Yeah. But yeah, you really got to have automation, or this is like incredibly painful. Cool. All right, one more. These would work. Now we have to upload this metadata folder. So to do this, we actually want to upload a whole folder. So you can do what's called a car, which is just like an archive that will give us like a root. Oh, you can also use this NFT up tool, which is probably basically like making it a car file like under the hood. Let's just give that a try. Just installing this real quick. So now we've got NFT up, sick. Let's see how this works. I've never actually used this tool, but alternatively, we could like manually install this IPFS car packet. No. We could pack it into a car file like manually, or we're just gonna, you know what, we're gonna try this tool. If it doesn't work, it doesn't work. I'm actually just gonna take the whole metadata folder. Oh my gosh. All right, well, hold on a second. I'm just gonna get that API key. I'm putting in the API key, and now we're storing the files. Awesome. So let's look at what just happened there. So this tool is great. That just actually made things like a lot easier. So notice we've got this is our CID or content ID, and we've got this gateway URL, which is like using their like little server here. If we click on that, notice here's our little folder, our one. And we've got our different JSON files inside, and then we've got each one has a link to its like corresponding image file. Perfect. All right, so this is exactly what we want. So this is actually ready to go, where we could use it. We could use it like in our contract. So this is what we're going to call the base URL of the NFT. So if we were going to use it with a minter, that would be it. Let's go back to our contract. As you can see, this is hard-coded now. In fact, actually, let me leave that to do. But let's just assume it's hard-coded. So now if we want this to work, we are going to put that there. We don't need the slash because this format function has the slash. And then we could write just like a little bit of a test for it just to make sure everything works okay. So let's write the test, and then next time we can work on not hard coding this value, and then we can also like work on developing our game a little bit more. But I hope that tutorial was like a little bit helpful. I know it's a little bit confusing to learn about NFT metadata, especially NFT metadata for like dynamic NFTs, but as you can see, like the tools like NFT up like can be like really helpful in terms of you can just upload a whole folder of stuff, which is nice. So yeah, there we have it. These are our different, this is just one NFT. So yeah, let's try tests real quick. In fact, we already have some tests. So this is calling the deposit. So let's make another one of these. And let's say it was one Juno, right? So boom. All right, so we're gonna change this token URI to our base token URI, which is this guy right here. And let's just check to make sure that this link is right. Again, automation tools are your friends for this kind of stuff. Wow, this is so much slower than Emacs. Oh my gosh. Normally we would not. Perfect. So that works great. That's right. I'm going to explain this in a second. All right, let's just run our so basically what we're doing, just to make sure, again, we're creating a test to make sure that when we deposit more funds, the token URI is structured correctly. So we're just going to write that right now. So I'm basically doing a query here. I'm passing in the dependencies, which is like all our different storage dependencies and APIs. I'm passing those in as a reference because query is read only. So if you're doing an execute, you pass them in as mutable. And if you're doing a query, it's as a reference. I'm passing in a mock environment. And then the query message is basically all NFT info. I pass in the token ID. And this is an option on that, but I'm setting it to none because I don't really care about that at the moment. And then lastly, I'm just like printing what the out of this query is. And so let's see. And then after that, we're doing another deposit. So we should expect the token ID to change. And right now I'm just doing those with print statements, but we'll be able to soon see if they work as expected. So we're just going to run a cargo test. And the cargo test does not show print statements by default. So we're actually going to add a flag here, which is no capture. Oh, and these are binary responses. So that's, and then we've got a failure because of one of our later assertions, but we're not going to worry about that. Let's convert the binary. That's annoying. There's a nice helpful from binary function in CosmWasm standard. So we're going to use that. This is a little bit messy, but we're going to do more stuff on testing soon. Oh my gosh. So that just, I think, needs a pointer. This also needs a pointer. Again, Rust screams at you a lot. It's like usually tells you exactly what you need to do. So let's add a pointer. Now this is going to want an explicit. So sometimes like when you're doing a query, again, Rust needs to know exactly what type something is going to be. So we're just being very explicit about the type there. All right, I think this should work now. The test is going to fail, but we should at least, yeah, see, now we've got our all NFT info response. And as you can see, we've gone from a sapling to a fully grown NFT. That was not what I expected. I thought it was a seedling, but let's go check the code. We're getting closer. So originally it was a seedling, and then we deposit without funds, that errors. So we might have found a bug in our deposit function, but at least we can be happy that the token UR is changing. It's just not changing to what we would expect. Let's get rid of this guy, or we'll just comment it out. Oh my God. I'm so helpless in VS Code sometimes. I actually don't know how to like comment out this line of code. I'm just gonna fucking delete it. Okay. Or was it? There we go. It's going instantly from seedling to full grown right away. So let's actually, now I'm concerned. We might have had a bug in our original code. So let's check it out.
Because if it's not greater than those two values, then it defaults to full grown. Right?
Yes. Oh my gosh. That was great. Who was that? Is that Cheddar?
Yeah.
All right. That was awesome. All right. Yeah. So that's the kind of dumb bug that will screw your DeFi protocol up really badly, which is why it's good to write a bunch of tests. Tests are great.
Should you flip it so that you compare it's less than the first threshold first?
We just want like nothing to happen. So I think we just forgot like an else if here, and we'll just add like another 0.
Oh yeah. And then okay, yeah, for else it does nothing.
So I think this will work now. Again, we expected the error. So seedling, okay, sapling, perfect. That's great. Amazing. All right, let's clean up this test a little bit. So we're actually going to get rid of this guy. We're going to check the current token URI is seedling. Date. We're going to do an assert equals here. And we're going to do token info token URI, and then we're going to expect it to be sum. It's an optional value, and we're going to expect it to be the seedling state. Oh fuck! And then we're going to make the deposit, and then we're going to expect it to be a sapling state. But one of the things you might notice is we've got like some code here that is like a little bit repetitive. So like this whole like function, if we were going to do this a lot of times, let's say we're actually making a game, like no need to do this verbal like query and unwrapping and assertion. You could easily just make a helper function for this. This would be a lot more important if you're like writing a complicated like game where it's like you want to check if something's dead or not. It's oftentimes really good to just make yourself a helper function. Then you can only do check token URI versus having to rewrite all this every time. Maybe we'll do some cleanup for that next time. Or if you're looking to sink your teeth into some code, try refactoring these tests to make them a little bit more readable and a little bit easier for us to write some new ones. So it could be good to have some helper functions that would allow us to break those out. Cool. All right, so I think this will work now. Perfect. So we just, I guess to cover what we just did in this step, and I think this is pretty good for today. Oops. I'll show you how to make a pull request. Does anyone actually want to see how to make a pull request, or is that like too basic?
No, dude, I want to see it.
So we just pushed let's actually name our branch something sensible. Let's just do example metadata. And we're going to push, actually, I'm going to push it to mine. Okay. Because remember, if I did get remote, I've got my own fork of this repository. So I'm going to push it to mine. This is an example for you all. You might not have access rights on the main repository. But if you contribute, you'll get access rights. But I'm just going to push it to mine. And then the branch name is example metadata. One of the things we covered today was we talked about how to structure some of this metadata. There's a lot more work to do there, and there's a lot more tools to look at. Again, this is something you want to super automate, but we worked on that. We broke up all our contracts into like separate like files to make things a little bit more readable. The wonderful Cheddar caught this amazing bug, which would have allowed anyone to get a fully grown tree without spending any money. And kind of basically wrote some tests to make sure that like our contract is behaving as expected, which was great. And then we actually uploaded the data to IPFS. It's like, this could be like a real NFT project now. So that's cool. But yeah, let's go to the GitHub. So if you want to make a pull request, it's pretty easy. You just go to code and chill. And notice like, it's actually smart enough. So earlier I forked this to like my own like personal repo, and it's actually, GitHub is actually smart enough to see that, hey, you already have a fork of this. And so I just have to come in here and click compare and make pull requests. And now you can see like all the different changes that were added. That's cool. And then you could add a nice little comment or explanation. Normally I would write like a better one. You could even assign reviewers. I'm not. And now that's a pull request. So you can see that it's actually coming from my branch and it's going into Cosmos contracts main. And now the tests are going to start running. So we have some CI set up for some basic linting and some basic testing. So let's hope that those work. All right, so we're running the tests. As you can see, it basically is going to run the test. It's going to compile the contract to WebAssembly and, run cargo format. All right, so we have some formatting errors. Let's show how you can easily fix those. If I actually do cargo FMT, notice like that basically just went through and automatically fixed all my errors with one command. How cool is that? Cargo FMT. And if we look at, I really don't know how to use this GitHub source control tool. All right. Someday, someone who actually knows VS Code can teach us how to use the built-in GitHub tool. So I'm just going to add those. And now I'm just repushing the branch. And now after this, we should ideally have something that works. So yeah, I feel like we covered some good stuff today, and hopefully this is slowly starting to make more sense to you, how to work with NFTs. and all the things that are involved. The contracts are one thing, but there's also all the like the metadata and getting all the images and stuff together. Don't discount how much work that is in an NFT project. Generating all those JSON files, making sure they're uploaded in the right way, and also testing them. When you upload because the metadata files have to match what's in the contract. Otherwise, people are going to get 404s and they're not going to be happy. Don't let that be you. But usually you can always like relaunch your NFT contract and fix it. I've seen it happen a couple times. But yeah, I think that's pretty good for today. In terms of like homework or whatever, this is not a real class, but for those of you that do want to get more involved, Elite Society is recruiting, and there will be like actual Juno and stuff that you can earn and access to some great opportunities and also mentorship. So some of the mentors will include myself, Reese, Zeke from DAO, Jack Zamplin, who's like super OG in Cosmos. So I think it's gonna be really fun, and priority will go to like people that show that they can do stuff and are trying hard. You don't have to be like perfect. No one ever starts out like perfect. Just like it takes hard work to become a coder, and yeah. But let's def fork the repo, play around, try to make some changes, and then I think during the week this week we're going to be like brainstorming what kind of game we want to make or how we want to modify this to make it a little bit more fun. Growing trees, fun, right? But I think we need to take it to the next level. So let's start getting our game design hats on, and I think this will be like a really useful example for people. But we're almost there. We have all the elements that we need to make a game, because we've got NFTs that actually store like real money and real tokens, and we've got dynamic NFTs that can change as like the game progresses. Some might die, some might evolve, depending on what kind of game we make. So we have actually all the pieces we need. Now we just have to like get ChatGPT to design our game, and then we just make it, and we'll fund Elite Society with the proceeds, and it'll be great. All right, with that, are there any final questions? Otherwise, I'm gonna go smoke.
I'll just comment on the source control plugin. It normally, like when you make changes, it'll just show the file changes there. Like that one right there, it showed that there's one file that hasn't been committed, and I just don't know why it's not showing up on yours right now.
Yeah, I'm really confused. Is it because I have multiple folders open here? Also, this should not be.
It could. It might be because if you look at the bottom left where it says branch main, it was showing what you were on before the metadata one. So you may want to open the folder as like a root, so it knows where the Git repository is.
Exactly.
Let's try this again. All right, now it seems to be like a little bit smarter about this. Cool. All right, I'm glad we're all learning this stuff together. And I think it's actually, someone pointed out it's good to watch me like stumble through.
I'll just point out, because when you said it looked better, it's that one disappeared because those changes that you made were already committed. So if you make a change right now, it might show up in those files that need to be staged.
Cool. And we just merged this. Feel free to play around with that metadata example. Maybe you want to work on like developing a script that would allow you to like easily generate like a whole bunch of NFTs. And now I think if I resync this code and chill main, I still get really confused by this. Is a mystery to me, but I'm also learning. Did it work? All right, maybe it'd be really great if someone wants to, we should have just a VS Code tutorial day, and maybe someone else that actually knows how to use it can help teach me how to use VS Code, because I'm so lost. It just doesn't make sense to me. But it's a great tool, and honestly,
in this window, sorry to interrupt, you're back to the window with multiple folders open. Did you have two VS Code windows open?
Oh, yes, I'm an idiot. Oh my god. All right, so let's just do I'm not actually going to commit that. Oh, okay. Yeah. So that's working now. So I guess moral of the story is don't open more than one folder in the workspace kind of thing. All right. Okay. I think if you wouldn't mind, we should actually do a whole space on VS Code and how to set up VS Code. It'd probably be useful for a lot of people, including myself, though. I think it's probably fun for people to watch me struggle with VS Code and then also struggle with Mac key bindings because I don't know what I'm doing. The only reason I have a Mac is actually just to use Ableton, so I'm just like so lost. But yeah, this is great. Let's do it again next week, and thank you everyone for your help and for spotting some bugs and telling me really dumb things I'm doing in VS Code. I really appreciate it, and let's keep it going. We're gonna keep it going. There's a lot more to do. You know, if you get some good shower thoughts about what this game could be, let's just pop them in the chat. We'll start working. But we're getting a lot closer now. I think we're back actually ready to. We have all the different pieces we need to really make this game come together, and now we just gotta design it, and then we get to work on the next part, which is the front end, and we might even have some guests come in for that. Get ready. All right, it's been 2 hours, so I think it's time to move on. Enjoy the rest of your day or evening or your morning, wherever you are, and peace. Have a good one.